Hello everyone. In this lesson we will explore the Rail tool in Alias. It builds upon our previous lesson, or previous session better say, which covered the profile tool and its counterpart, profile blend. Why? Well, that's because the Rail tool is part of a tool set focused on profile generation. It uses similar core options and math as its relatives, especially in how it interpolates and aligns profiles along a path. I will revisit this briefly here, but for a detailed breakdown, see the profile video, link in the description. You can review it after this lesson or before, if you prefer. So, the Rail tool. Now, the Rail tool is designed to generate profiles, but unlike the profile tool, it focuses on continuity and smoothness rather than profile accuracy. And that's because Rail tool is a sculpting tool. It's designed to morph things to sculpt them. And because of that, it has some properties that let's say reserved for sculpting tools like a square tool. And that is the reason, by the way, why newcomers has difficulties to decide which one to use in what situation. And we will address that. But first, let's cover the fundamentals. So right now, as you're going to see, my Rail tool is already activated. Now, if you're interested where it is in the palette, it's in the palette under the Surface tab, under the Swept Surfaces category. As you can see, this is the family of the profile tools. And as I said, the Rail tool is a tool that creates profiles. So the simplest profile you can create is when you activate your tool, you click on one generation curve and one rail. And that means that we will build the profile based on the profile curve. This is the profile curve, for example, and this is the rail curve. So if I'll click on one and then click on another one, as you're going to see, you have your interpolated surface, which is actually called a profile. So this is quite a simple profile, and as you're going to see, it placed pretty conveniently. So in most cases, this is exactly what you're looking for. You have a profile curve which was swept around the rail, interpolated around the rail in a very specific manner. And this manner was pretty convenient for you. But this is, of course, not always the case. And behind these, looks like a very convenient orientation, there is a lot of math and actually a very intricate method to interpolate the profile along a rail. I'll explain the nuances of that in the profile tool. Once again, link in the description. I just want to iterate that this is quite a complex thing, and the Alias never disclose the actual algorithm sitting behind it. The only thing we know is that, well, first of all, it takes a lot of burden from your shoulders, make it sit itself, and it orients the profile based on either a SLIRP, which stands for spherical linear interpolation, a Bishop frame, and RMF, which stands for rational minimizing frame, a combination of them or derivative of them. We don't know. This is a know-how of the Alias developers. They don't want to disclose how exactly they do it. And even though that, you may say, well, Alex, there's just you're talking too much about this, why it is important. Well, let me show you. There is a different curve. Now, this one was quite simple. The rail was simple. Now, this one has a very aggressive turn, which means that it has excessive torsion of a curvature. And if I will try, let me just undo and do the same stuff with the basic settings and create a different profile here, you're going to see that even though that it has excessive torsion, it was able to conveniently place the profile. But the question here is it the proper way how you want it to be? Maybe you want this to, orient quite differently. Maybe you want this profile to be, rotated somewhere to the left and maybe then somewhere to the right, or maybe you want that the ending one be in a little bit different state. Why it rotates it this way? Why it doesn't really rotate it like down here, for example, right? And that's because of the algorithm. It tries to minimize the torsion and basically by that predict the most natural flow of the profile. And this most natural flow of the profile from the standpoint of Alias is not necessarily the profile you're really looking for. And to control this automatic algorithm, the profile tool has a lot of additional controls and options. Rail tool, on the other hand, lacks these features. It has only one, which we will talk in a bit, but that's pretty much it. And it may sound like a big inconvenience, but the fact that the rail tool is more of a sculpting tool and it's very localized, and we'll talk about the localization a little bit later, it's not a big issue. If you didn't watch the previous video, watch that. If you watch the previous video, you may think, well, where is my normal directions? How am I gonna set it up? Well, you actually don't need to. The rail tool designed for different purposes. So just keep it in mind. Let me just undo and let me hide it so it will not be in our way. So let me zoom in to my original example and we will keep going. So one generation, one curve, to construct with that, you just click and click. That's it. No any additional confirmations. Now for the just the few limited controls you still have, even though that, once again, it's a very automated process, they are located in the sweeping mode. So here in the sweeping mode, and this list of options dependent on your main settings. So if I'll undo, you're going to see one generation curve and one rail. If I'll switch, you're going to see that the options changing here. And that's logical because they reflect the main changes. By default, the few options which we still have to control the orientation are located under the sweep mode. So once again, let me just construct this and open up the sweep mode. You're going to see I have three options: view, parallel, and neutral. By default, it's set to neutral. It's really similar to the radial frame travel in the profile, tool. So basically what it does, it takes the profile and it rotates that based on the curvature direction of your rail. So if your rail curves, it will follow. Alternatively, if it will switch to parallel, it will take the original orientation of the profile and carry it through. It will not try to rotate it based on the curvature direction of the rail. So this is two kind of main differences. In most cases, it's either or. They're pretty convenient to use, very similar to the frame travel in the profile tool, serves the same purpose. On top of that, we have the view, which is once again very convenient, not very useful though, but pretty convenient. You can set up the sweep projection from the plane. So with XZ, YZ, your active one, your active window, or user defined, where you can just literally place the plane where you want. Rarely used. The sweeping projection, it's either the active XYZ or you'll never use it. Instead, you use parallel or neutral. And in fact, 90% of the time, you use either the neutral or the parallel. And from these 90% neutral and parallel, in 95% probably you use natural. So this is the standard approach. But there is a nuance here. As I said, there is a three modes, but this is not all of them. There is actually one more. But because of the interface of the Alias and the way how, because of the user experience or flaws in the user experience, you don't see it. So if you undo and before you create anything, you open up the sweep mode, you're going to see there is another one. It's called spine. Now the spine is very, very similar to guide curve in the profile tool. The math is slightly different, but the purpose is the same. So you use spine to define the orientation of your profile. Now remember, we have only one generation, one rail. So one gen, one rail, which means we have infinite amount of possibilities of how it may be. Right? Now, Alias, of course, constrains us with its own algorithms, as I mentioned before, but it gives us at least slight abilities to morph and change that. And as the and is not defined and the second rail does not exist, we can switch to the spine method. It's true only for one generation, one rail. And now, if I will click on the generation, then on the rail, and then on my spine. So this is the spine, this is the curve, which I will be using as a controlled curve. I basically just copied that and move it aside, which already changes, makes the effect, and then I click on it. Well, you may say, well, this is the same. This is not the same. So if I'll switch it now to neutral, you're going to see how it changes. So this is the neutral mode. We already discussed. It does it automatically. It rotates the generation around the rail and everything else it takes based on the slurp, bishop, RMF, or whatever. But when it is on spine, it still works in its internal algorithm, but now it gives you an ability to change this based on this curve. And in fact, it's already working. So if I will activate the CVs of this spine or this guide curve, and I can move it up and down, left and right, you're going to see how it will actually affect the profile. Now, if you notice, it will affect everything except the rail and the profile, which are already defined, because we know where they are. But it kind of specifies the unknown. Basically, all of this part can be tweaked, and we can do that using these guide curve, or a spine as it's called here. This is not very useful feature, even from the sculpting perspective. And once again, rail is a sculpting tool. That's its main difference from the let's say the profile tool. But even though that exists, it's difficult to control. So if you miss that, and it's very easy to miss it, because if you create the profile first and then open it up, it will not be here. But even if you missed it, not a big deal, really. Most cases, no one really used this one. And you don't really need to, and you'll understand a little bit better why. So the next two options are the sweep pivot and fixed curve. Now, as I said, it's really settings dependent. So if your generation curves is more than one, or the rail curves more than one, you'll have a different set. So the less amount of information you provide, like one generation curve and only one rail, there is a lot of unknowns, and that means that you have more options. So the more you define it, the less options you will have, basically. Which makes sense, isn't it? Now, the continuity, as I said, if I said I don't remember, I will talk closer to an end. For now, we will work on the next two. So sweep pivot and fixed curve. They work in tandem. So basically, one dependent from another, and they are linked. So by default, the sweep pivot is in effect, and by default, it is set to closest. What does it mean? Now, your curves, your generation curve, your profile curve, and your rail has these point of connection. Basically, I build it this way because this is a very convenient way to start doing rails. And let me just kind of go back to neutral. And the sweep mode closest automatically understand the closest point and use it as a pivot. And that's why we have this very logical and convenient result when you create one generation, one rail from these settings. But they can be actually not, they may necessarily, once again, they may not touch, and it's actually fine. So, for example, I have this additional profile here, this line, right? And I can use it with the closest settings turned on and the fixed curve set to rail. What will happen if I'll click and click? The closest sweep pivot will still understand where it's supposed to go. So it takes the closest between the two, so it was somewhere here, and as you're gonna see, it tossed it onto the rail and placed it on the rail. So for the placing on the rail, the fixed curve is in effect. For sweep for the pivot, the closest method automatically calculates the closest distance, and you will get a convenient result, right? And you can switch it. For example, from the rail, you can switch to generation, and now it is on the generation, or get back to the rail. And of course, you can change the sweep pivot. Now, for demonstrating that, I will undo and will use the standard example. So let me activate it again. And the fixed curve is still the rail. And in 99%, you want that your fixed curve will be rail. Very convenient way of working. And instead of the closest, you switch it to on curve. So when you do it, as you're going to see, something changed really drastically. So first of all, you're going to see it's not now the fact that they just flip down, not a big deal. That's because of the handles. So there are two handles, each one of them is the generation pivot, and another one is a rail pivot. The reasons why it just immediately jumped down is because when I created the profile, I started the curve from here when I created that. So this is the beginning. But I can take this pivot and move it, literally move it along the profile. And this is not the pivot of the curve itself. This is the pivot for the sweep. So as you're gonna see, when I move it down, the profile slides. It is sitting on the rail, yes, but it takes the pivot point for the profile based on where I placed that. So if I'll place the profile pivot here, it reflects that. It takes this part, put it down there, and then create the profile, right? So I can move it down, move it down, move it down, move it up, and you're going to see how, well, actually convenient it is. So this feature is very similar to slide to target in the profile tool. Now the slide to target has much more options and much heavier in terms of calculations. There is more options, but it can do the same stuff. So it can slide around. And the same thing, if I'll put it down here, it'll be literally what was originally with the closest. So it takes this closest point. Now I can move it. And the same I can do for the rail. So for example, if I'll take the rail and say, well, no, I would like it to be from here. Now the rail will still construct the whole rail, the whole length of a rail, if I decided to do so by default. It just places the pivot point in the different position. And because of that, it skews the profile. So I believe it's quite visible here that the more I move it, the more it will be skewed, which I believe quite logical. Now the rail pivot rarely changed. In most cases, it's where it's supposed to be. And what we do in most cases, if we really need to, is we will slide the pivot, because it gives us an ability to slide the profile, like to move it under another object, for example. So there will be an overlap. But sometimes the sliding the pivot may be useful if you decide, for example, to twist it from the very specific point in your model. For example, here in a curve network, you have some important point of interest from which something else will be built, and you can literally snap the profile which was built somewhere else, to the point organically, and obviously it will shift and skew the profile. So this is the on curve. On top of that, we have another one which is off curve, and they are very similar. The only difference is that, well, the rail still keeps its own pivot, but the profile now has this pivot change that's called Gen 1 space pivot. That means that now I can snap it using the standard snapping tools to the curve and just work the same way, or I can just move it where I want. So I'm not really tied to the profile anymore. I can just, literally place it where I want and snap it to points or other geometry if I need to. Now, I wouldn't say this is a very useful feature, but I didn't really use it in my career, I believe, once, but it's still there. So maybe you will find a practical usage for that in some very, 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 very specific situation. But it's there, and maybe you will use it. So it's either the closest or on curve. On curve has some usage and practice, and the closest of course does as well. So okay, let's go to the next one. The next one is the rotate X form and scale X form. So as we already discussed, let me undo and reset that basically, so everything will be as it was in the beginning. So when I created the profile, and I don't have a lot of controls, so I have a lot of unknowns. That means that as this one is basically free and it works under the Alias's internal algorithm, it gives me the additional options to, how about maybe you want to rotate it? Do you want to rotate it? Maybe I do, and I can do that. And here is this option which called Xform Rotate, which gives you an ability to rotate this stuff around. Basically, as many revolutions as you want. It's set in degrees, not in radians, so you can do it this way. And in fact, there is quite a few people who just on the concept phase, and this is important, on a concept phase, this is not the final result, of course, they use it to create coils, springs, threads, stuff like that. I am not advising this because there are better tools of doing that, especially parametrically. So you better do it in the Grasshopper or in the CAM systems like Fusion 360, or maybe some solid body modeling tools, professional ones like SolidWorks, but not in Alias. Alias is not designed to do that. You can, the result will be subpar, but you have an option. Maybe you just want to rotate it a little bit. Why do you need to do that, to do so? Why didn't you create the curve for that? I don't know. Alias give you an ability. Here you have it. And the next one with it is the scale. So you basically, once again, all of this part is unknown. You can scale it if you want. Here you go. Do you really need this? I don't believe in that. Like, I don't find a practical usage. Well, once again, except of a quickly and dirty way of creating coils, I wouldn't see a lot of a reason of using that. So in most cases, it's just set to 1, I believe. So it's not in effect, and the X form set to 0. All right, what's about the next one? The next one called the curve segments. The curve segments is really useful, used very often. So it gives you an ability to define the area of effect. So for example, you have a very long rail. You don't want it to go that far. Well, guess what? You can change it. You can click on the handle, move it, and it will be shorter. Same with the profile, can be shorter. Now, if I will take this one, for example, the generation start, it will go, like, you know, it's always takes in an effect. And you can basically, using these handles, define the very specific portion at which you want. Now, for example, maybe I want to, create only part and make it very lightweight, and then the next part create manually. So basically, maybe it will go with some aggressive turn here and something else. So there will be not a one curve, but the two curves. And we'll talk about these two curves in a second. So pretty useful feature, use it. The next one is explicit control. I believe this is no-brainer for you. It gives you an ability to change the complexity of the polynomial by bringing more or less degrees, or more or less control points or spans. Now, the continuity options, like how many spans it can bring, I believe this is self-explanatory, and the collinearity, and especially collinearity, we will talk in conjunction with the continuity a little bit later. Right, so let me undo, and before we go to a little bit more complex example, a little bit more constrained examples, I would like to address one important thing about the curves. So in this example, if you remember, I have a one sweeping curve and another sweeping curve. One was used for the profile curve and another one for the rail. Now, in this example, which is very similar visually, structurally it is different. So here I have not a one curve, but two curves, and not a one generation curve for the profile curve, but two of them. And this is totally fine for the profile tool, but it actually not that fine for the rail tool. Rail tool is very localized. It takes only one curve per rail, or one curve for generation. It can't do more. I would say this is to some extent a limitation, but we always have a profile blend which can serve this, solve this purpose, or the profile tool which can, it's not the purpose, sorry, solve this issue. So the rail tool is very localized. It is a good thing and a bad thing at the same time. It depends how you look at it. So here, what that means is that if I will try to do a one generation, one rail again, and I will click here, if I will click, you're going to see it selected only the portion of the profile. I want to have the whole profile. So if I'll keep clicking, the next click will bring me rail, not the generation. So when I click on here, you're going to see it just actually constructed me a rail. So same here. If I will create the first rail, or maybe one generation curve, and I need the full rail, and I click here, as you can see, it doesn't go further, even though that it is absolutely continuous. So once again, the rail tool always take one curve at a time. It can't do more. Of course, it doesn't mean that you can, do multiple parts, right? So for example, I can keep going, and I will create the part. It just will be 4 different segments. And if your profile is simple enough and there is a lot of freedom for you to move, naturally interpolate using not naturally interpolate using Alias internal algorithms, it actually will be most likely continuous. And indeed it is, even though that I actually didn't specify it here. So let me undo it. So just keep it in mind, this is a limitation of a rail tool. And with this knowledge, we can now go into the more constrained examples. So this time we will use one generation curve, this one, but 2 rails. So let me click, and as you're going to see, we immediately have a different set of options. So first of all, the most prominent right now is the scale. And if I'll open up, you're going to see there are 4 options: rotate, no trim, rotate and trim, non-proportional scale, and scale. Now by default it's set to scale. It always set to scale. Profile tool use the same methods that use the scale, and the scale and non-proportional scale actually not really described by Alias deeply. It gives us just the general hints, and I will toss it to you. So on top of that, we have curve segments already described in explicit control. So much less options, isn't it? Now it looks like so, and in fact it is, but these options are quite important. Now let me illustrate. So by default with the scale, I click on the one generation curve, then I'm keep clicking on the rail and on another rail. And I will give myself a profile which basically swept along the rail 1 and constrained by the rail 2, basically by default scaled between them. So basically this is once again a very convenient way of doing this. I believe this is quite obvious. So if the rail 2 will be somewhere here, it will be scaled proportionally between these two profiles. That's what the scale does. Now let me activate the CVs so it will be a little bit more convenient and easy to understand. Now, if instead of a scale, I switch to non-proportional scale, as you're gonna see, the center CV point changes a bit. Once again. Now, why it's happening and what does it mean? What does it mean non-proportional? How? When? Well, as I said before, Alias doesn't really want to explain in terms of math how they actually do that. The only thing they say is that the non-proportional scale, and that's the reason why it's non-proportional, is because it scales along the vector that connects rail curves. So for example, the vector which connects rail curves like this, like this, like this, like this, and so on and so forth. So it samples that and it scales along a vector. So that's why you're gonna see this difference, a visual difference between the scale. And that's why the non-proportional scale called non-proportional, because yeah, indeed it is non-proportional. So the uniform tries to keep it more uniform. So the standard scale is more like a uniform scale, and the non-proportional is, you know, very vector specific, vector and distance specific. Now, which one to use? It really depends on the situation. Sometimes one works better, sometimes another works more convenient. You know, once again, rail is a sculpting tool, and this is a sculpting option. And of course, you can always delete the history and take it at your own hands and use some CV massaging and scale it the way you see fit. This is sculpting, specifically a sculpting tool. Now, the curve segments works the same way. So if I will go to the curve segments right now, I can make one. Oops, I can make one of them shorter, maybe this one, and so on and so forth. I probably already explained it. But a part of the non-proportional and scale, there is two additional options, and they are true only to the situations when you have one generation curve and two rails. So one profile, two rails. And they are rotate no trim and rotate end trim. Now, if I will click right now on rotate no trim, what will happen is the profile will fall off the rail number 2. So look at this, bam. What's going on? Now, what the rail rotate no trim, it's actually horrible naming, and I'll talk about that in a sec. So what the rotate no trim does is it tries to keep integrity of your profile curve. Your profile curve is Gen 1, and it tries to keep this integrity of the profile when it sweeps around. So you have two rails. So the rail 1 will become to be the dominant rail, and the rail 2 is a supportive rail. So with the settings rotate no trim, it takes the main one as the key sweeping rail, and the generation 1 as a rigid form. And even though that, yes, it bends and deforms it, it tries to minimize that. And you're going to see that the more natural flow of the Gen 1 will be right there, not here. But it doesn't mean that the rail 2 doesn't take, it's not took as a consideration. It does, it takes it as a consideration. And here you're going to see the and remember, I didn't really specify the and. So the rail tool with the rotate no trim understands where the rail 2 is. It places the end where the rail 2 ends, but it interpolates between the two the way that it will try to make the rigidity of the generation 1. So the other words, the rotate no trim gives you a more natural position of the, or not the position, but the more natural profile, which is supposed to follow the first rail. More natural flow of the generation 1. And this is a very useful feature, because when you create curve networks, you know, you're guessing. You don't know where it's supposed to be. Maybe it's supposed to be here. Maybe it can be a little bit further away. Maybe you don't, you know, you're in the beginning of modeling. You don't have any scan data, nothing. You have only a sketch. So you don't know. And when you create your curve network, and you can quickly and easily check it using the rotate no trim, and it will show you where it actually goes with this rail, and you can tweak it. Now, just to quickly prove my concept that the main rail is the main rail, we can just swap it. So this is the first generation, the first rail, and the second. As you can see now, it follows on the other side. Once again, because they are not really working with each other too well based on this profile. And this is a good feature because now I can just, I can stall this edge and reconstruct my rail, and it will be much more natural for this profile, for this generation curve. Now, what is the rotate and trim does? Now, if I'll click on this, you're going to see that now all of this bulging will go away. And what's going on? So first of all, let's go to the naming because it's important. The rotate no trim and rotate and trim, they have nothing to do with the trimming operations. This is just a bad naming. What it actually does, rotate and trim, that rotate and no trim, what it actually does is, if I will activate the CVs, what it actually does is that it construct the profile, as I said, with the natural kind of keeping the rigidity, and it has these the scale based on the rigidity of the surface. Now, the profile. If I will switch this to rotate and trim, you're going to see that it's the scale still the same. So this is not the same as scale, for example. You see the scale and the rotate and trim has a different scaling factors. That's because the scale interpolates and between very cramped area. So the rail 1 and the rail 2 are the rigid edges, and it just scales between them. The more natural using the whole area. The non-proportional, I already mentioned, it works localized. But the rotate and trim, as you can see, it's quite different. It's very, very similar to rotate and trim. Basically, it's just a skewing. Why is that? Well, because the rotate and trim by default works like a no trim. So it uses a no trim, and then it rebuilds the no trim to the new rail, forcing it to be. That's why they're very similar. You just kind of shift it in. So the rotate and then trim scale and the standard scale will be different. And now you know why, because by default, it takes the parameterization of a rigid geometry and then kind of squash it a little bit using the same parameterization. So it can be quite useful if you really want to bring less distortion or more uniform distortion based on the original generation curve, not like, uniform scale, then you're going to use rotate and trim. It will do a little bit differently. But once again, this is a sculpting tool and there is no right or wrong way of doing that. So what you really want to take from that is the fact that the rotate no trim give you a really good edge, natural edge for rigid profile. And you can use it to create the proper curve networks. Right, now the curve segments already explained, and this is basically it for the one generation and two rails. So let's switch to the 2 generation and 2 rails. And as you're going to see, we have additional controls, different controls. Now in the transform control, as you can see, there is no trimming anymore, no trim and trim. There is only scale and non-proportional scaling, but instead we have the blend control. We'll talk about that. So when the generation curve is set to 2 and 2, that means that I can take 2 generation curves, one and the second one, and then 2 rails, one and the second one. And it will construct me a profile. Now the proportional and non-proportional scaling works literally the same, but there is a blend control, which kind of give you the bias over the one generation curve on another. I will talk about that just in a sec on a little bit different example, but before that, I would like to address one very important question, and this question stands as: does order matters, and does the generation and rail curves selection matters? And the answer is yes, of course it is. So which one you pick as the generation curve and which one you pick as a rail curve, as well as which one become to be first and which one become to be second, is important. Especially which you pick as a generation and which one you pick as a rail, because of the nature of the tool. So here, for example, I have two completely identical curve networks, but two different surfaces. One of them, this one, let me actually activate the history. As you can see, for this surface, once again, boundaries are literally identical. But for this surface, these sides are the generations, so basically it's profiles, and the rail 1 and rail 2 are supportive rails. So what will happen here is that Alias will take the profile with Gen 1, it takes all of these CVs, and then it transforms it, interpolate to the Gen 2. And it has, as you can see, quite the different structure. And it so basically transfers one, interpolate to another state, and another one, interpolate to another state. And it interpolates it based on the guide, which is a rail, your rails. Alternatively, here, it's actually swapped. Now, the generation curves are top and bottom, and the rail curves are left and right. And you can see what happened. Now the generation curves takes all of these CVs, all of these control points, and interpolates them to Gen 2. So you can see it's quite a different profiles in comparison to these ones. And the rails become to be a rails. And if you look at them, you're going to notice that, let me do it like this, you're going to notice that they're not even close to be similar. So this is two completely different surfaces, and that's because they have a different profile. So this surface maintains this profile to this profile, and this surface maintains this profile to this profile. The only situation when the order doesn't matter is when you have fully symmetrical objects. But for the fully symmetrical objects, you do not need to use rail tool at all. It's actually give you a lot of headache, and we will talk about that in a sec. So knowing this, we can go back to the blend factor. So the blend factor give you additional bias of interpolation between one profile to another profile. So right now it says to 0.5, so every part contributes equally. This one contributes 50%, this one contributes 50%. If I move it to, like, for example, to the left, it means the generation 2 contributes to the almost whole of the surface except of the very end. So this is still the Gen 2, Gen 2, Gen 2, Gen 2 following the rails. Now, alternatively, if I'll put it to the right, you're going to see that the G1 actually interpolates mostly and takes the control until the very end. And this is something in between. Now, this is quite a useful feature. I'm not saying that this is something you must do all the time, but sometimes this bias can help you bring continuity and the proper structure of your surface. So use it. Don't forget about this. Right. Now these out of the way, let's go to another options, and this option is the second, or the more than one generation curve. So go back. Let me reset everything. So now let's go to the next example where we have 2+ generation curves and 2 rails. Now, once again, you can use one. If you go to 1, it's very similar to 1 and 1, except of the fact that you have additional controls here, and you have this additional rebuilt interior gen curve. We'll talk about that in a sec. So I will, as we already described these ones, let me just switch to 2+ generation curves and 2 rails. So what these options give you is they give you an ability to create more than one generation curve. As simple as that. So for example, I will take one, and then the second, and then the third. And now when you have 2+, you need to click spacebar when you finish, because it can be 2, it can be 3, it can be 4, it can be 5, and you hit spacebar to accept, and then you pick your rails. You can use either 1 or 2. So I will use 2, like 1 and the second one. And here we go. So now we have the structure which takes into consideration additional generation curve. Now this additional generation curve will always be a span, or it really depends on you can switch it using the explicit controls here, but the additional generation curve between the first and the last will be a span. So you have this span, which actually now contributes to the whole shape of the geometry, and Alias takes it in consideration. That's why it's at 2+. Now here we have this option called rebuild interior gen curves. It means that it can rebuild these curves. It's not always work. I don't know, will it work here? No, it doesn't. So it tries to reapproximate it based on the newly created surface. Not always useful, but I have this option. As for transforms, you have scale and non-proportional scale. You're already familiar with them, and explicit control. Now, the important nuance here, and we are slowly getting to the continuity, is that the Gen 2 never has its own the additional generation curve, like everything in between, doesn't have additional controls for continuity. So that's because it is a span, it's supposed to be continuous. So that's why when you pick, instead of a 2 and 2, you pick 2 plus and 2, you're going to see that the generation 2 changes the name to last generation, because we'll be using the continuity. It can set the continuity for the edges. So the 1 and 3. The 2 supposed to be continuous. It's not always the case. Sometimes you have issues, and if you have a really complex rails, which actually quite rare, you may have some discrepancy here. And that's the reason why in the industry, in the practical examples, we rarely do so. We can as a temporary solution, but as a final one, no. It's always a separate pieces, and they will be realigned and tweaked. But as a starting point, you can use this. You can use this here, or you can use the profile blend or profile tool, and on the starting points to really figure out where your surface is supposed to go, does it work or not, and should you really keep working with this and do a proper A-class. This option is quite useful. So don't discard it completely. Just remember that it probably will never give you the perfect result, but a good intermediate result to tweak. All right, so this is out of the way. Let's now go to the continuity. So here, let me just... Right now, so very similar example. We have the part on the left, we have part on the right. They are our profiles, so they flow like this. This is generation, this is generation, and this is this rails. Now, if I really want to fill the hole, I can use the rail if it just makes sense logically. Once again, we'll talk about that a little bit later. So in terms of the continuity, I can use, once again, 2 generation curve, 2 rail. So we need to define which one will be our generation curve and which one will be the rail. Here, I believe it's not a brainer. So this is our generation curve, generation, which means that they will be the same. So the continuity here is set to position. I will remove explicit control for now, and now just keep going. So this is the first generation, the second, the rail, and the rail. And here we go. We have our patch. Now, if I'll check it, remember I didn't really set any continuity constraints here. It's set to, well, by default, position. So it basically just works only with position. It actually works, but if it will be difficult to spot here, but it's actually not collinear. Actually, I believe it's quite obvious. This is not a collinear form. So now, even though that I achieved continuity, just because this is the very accurate rail and you don't really need additional constraints, it's not the perfect result. So what I can do, well, first of all, I can switch continuity to curvature, and it will basically update that automatically, even though that it doesn't really bring the additional degrees, which it doesn't really seem that it really need a lot in this simple example. But you're going to see it's not collinear. So what I can do is I can go in and I'm going to say I would like to be collinear for the Gen 1 and Gen 2. And if I'll click this, well, something bad happened. What's going on? Well, the reason for that is because we just need to bring more degrees ourselves. Alias rarely properly does this when it comes to the rail tool. Yeah, and now it's just much better. And if I will check this, it will work. So as you're going to see, rail tool in comparison to the profile tool and profile blend, it has a concept of continuity, and this continuity actually works. Very similar, you may think, to the square tool. It's not the case, and you need to understand that when you create rails, rail always already constrained by the fact which is a generation curve and which is a rail curve. It always tries to preserve generation curve to maintain the flow and direction, sometimes rigidity. Even though it is a sculpting tool, it's still a profile tool. And this is a big difference between the profile tool. Well, the profile tool is completely different, even though that it looks and looks like it can do the same stuff in some situations. And that's where we get to the question addressing the main question: when you're supposed to use the profile tool and when you're supposed to use the rail tool. And this is a really good example, I believe, to demonstrate that. So here I have this curve network, and I constructed slabs to, let's say, to fill the hole. So imagine that I need to fill this hole, and it has 4 sides, and you can use either the rail tool or a square tool. Now, I'll probably talk about the square tool in some of the upcoming videos. It's actually very simple in comparison to the profile family of tools. You know, the profile tool, the profile blend, and the rail are quite complex in terms of what they do. The square tool is very convenient, really robust and powerful, but very convenient. Doesn't have a lot of options, but a lot of power. So, which one you will use here? Now, some may say, well, it doesn't matter. Some may say, well, you need to use square tool. Some want to say, well, why not to use the rail tool? It doesn't matter, right? It matters. So first of all, let's go and just create this patch using the rail tool and then the square tool, and then I will tell you what's the problem. So the generation curve set to 2, the rail curve is set to 2, the transform mode set to scale, blend factor, we don't even want to consider. So I will not use any collinearity. I will switch the continuity straight to the G2 and keep going. So for example, as the model is symmetrical, order doesn't matter in this case. So which one will be generation, which one will be rail, doesn't matter. It's literally symmetrical. So it doesn't matter. Click 1, click second one, click third, and click fourth. And as you're gonna see, I immediately has curvature. No problems whatsoever, right? Kinda yes and kinda no. Now, once again, this stuff is not collinear. So these CVs are not collinear. They're not lying in the same line. So even though that I achieved the curvature, quite decent curvature, I would say. Well, not within its issues, but it's just the nature of my curve network. So it looks like the rail tool actually managed to do a pretty decent job, but it's just not collinear. So let's bring collinearity, and I will need to bring collinearity for gen and for the rail. So let's do that. Okay. All right, what's going on? So as you're gonna see here, the tool failed miserably. It's horrible. So I can go into the explicit control and try to fix that, maybe by bringing more degrees, and you're gonna see it's not even close. You're gonna see how big the gaps are. So what's going on? Why with collinearity rail tool failed on you? Not necessarily right now on me. Well, that's because the rail tool is not holistic. It takes priority of a generation curve over the rail curve. So when I said that this is the generation curve, it means that it takes these profiles and move it around these rails. And when I ask it to be collinear, I'm asking the profile to be collinear, and then toss this collinearity to the next side, which is supposed to be collinear as well. And that will be like the main constraint of the system, because I really bring the collinearity. But there is another constraint, and another constraint is that it's supposed to follow the curvature. And when I will do that, so for example, I will go to Gen 1 and Gen 2, activate this, you're going to see what will going on. So it tries as hard as it can to really achieve it, right now, to achieve the collinearity. Let me just kind of bring that back to, 5 by 5, for example. It's really visible here. So it really tries to be collinear, but at the same time, it's supposed to follow the rail, but it is a secondary operation. So it did the generation first, then it goes to the rails. And when you already tweak the generation curve without the context of the rail, you failed. And that's why the collinearity for this one doesn't really work for collinearity here and for the rail here. So your profile is now distorted, your curvature is now distorted, it's not even following the rails anymore. Because once again, it does generation first, then it tries to do the rail, keeping the generation collinearity, and that's why it's failing. So remember, the rail tool always creates profile. Its goal, its job to create profiles. Its job is not to create patches. Its job to create profiles. If your patch, or basically the hole, in the form of the profile, mathematically speaking, technically speaking, logically speaking, yes, it will work. But if it is a patch in 3D space, it's not. And for this reason, the proper way of using it is using the proper tool is to use Square Tool, because Square Tool, in comparison to the Rail Tool, doesn't have this artificial constraint of a profile. It is holistic, which means that its job is to take all the edges, and you're supposed to have 4 edges, of course, for the NURB surface in general. So 4 edges, it will take these 4 edges and it interpolates between them to accommodate to every single one for the desired continuity. And as I said, it's holistic. It tries to find the balance between all of them, and it's willing to morph the surface to accommodate this. And the Rail tool, once again, it tries to preserve the the profile, even though that it's much morphier and sculptier than the standard profile tool, because it has a concept of continuity. So instead of using the Rail in this situation, once again, you still can, but without the collinearity, you can undo. And instead use the Square tool. And once again, I didn't really explain the Square tool. Most likely you already know the basics. It's very, very simple. So let me just create all 4 edges and just switch it to curvature. And right now, if I will check the continuity constraints, well, it's actually working because it just brings additional spans. I don't want that. So I'll go to explicit control, switch it to 5 degrees by 5 degrees. I'm still having some issues here, and that's because it's because of the natural blend between the two, slight discrepancy on the form. But in the Square tool, for the Square tool, it's not a huge issue, because the Square tool, and I can eliminate it by bringing span or bringing more degrees, but a part of that, I can just make this collinear. And in this situation, it actually works flawlessly, and it actually gives me the proper structure. The Rail tool without collinearity doesn't really give me the proper structure. Well, the Square tool will. So, once again, the Rail tool is the tool which is designed to bring to construct profiles. It's not designed to build patches. And even though it can handle it sometimes, it's not guaranteed, because it's just not designed for that. The profiles is what the Rail tool is for, and the patches and organic transformations of the edges is what the Square tool is for. So, as a conclusion, just a final words. Rail tool is a sculpting tool that, let's say, give you an ability to create profiles with desired continuity and then morph them. It has limitations. We already discussed them. So only 2 rails, 1 curve per each, and limited options to correct orientation. So it typically used either on a prepared network, or let's say as a quick way to build technical slabs that guide something else, right? It's not designed to be holistic like a Square tool. It's designed to create profiles, not patches. So use it sparingly when situation favors, and ditch it when it's not. And and that's it. Thank you very much for watching, and I will see you in the next one.